Hello everyone. This is going to be the video for Lab 6, the Brainstem internal organization. This is a pretty detailed lab, and so rather than go through in the same manner that your course pack is going to work you through, we are just going to start from the most inferior portions of the brainstem and work our way superiorly, and really just go from there and hit the most important structures that we can see at each one of those levels. So once again, this resource is coming to you via the Scrubs team, which is the Student Collaborative Resources for Understanding and Brody Success. And I am Ryan Tiggerson, a Brody School of Medicine student in the class of 2025. And so going through the mission statement for Scrubs briefly, Scrubs is a student-driven initiative that is aiming to supply supplemental resources for the current and future cohorts that will pass through Brody. Members of Scrubs are participating in a variety of subcommittees working to create resources for students, by students, and this aims to offer a unique perspective of a student that has walked through the class and gone through the same process to give you resources that we wish we had been exposed to during our time in the course. So if this is something that you are interested in becoming a part of, we always welcome more participants, and we hope that these resources are useful for you in the future. And as a quick disclaimer, these resources that are included in this presentation are developed by students and not by faculty, so there is the possibility for errors, although we do our best to mitigate this via different stages of vetting. If there's a contradiction at any point between this course material, this material presented and the material that you're presented within your course, please go by your coursework. Additionally, this is a supplemental resource and is not a replacement for the instruction of the Brody faculty. Especially for this particular video, we will not go into as much detail as your lab course pack does. However, we will be hitting some of the high key notes. So with that, let's go ahead and get into some of the material. We are going to start with a brief overview of the different components of the brainstem, and I'm just going to pause for just a second on these next couple of slides. I'm not going to go into them in much depth, but these are good overview slides for if you're trying to go through and piece together what tracks and what nuclei you should be seeing at every single spinal level. So keep in mind that we're going to be starting with the medulla, and then we're going to be working our way up to the pons. And then once we get from the pons, we're going to go more superiorly into the midbrain. And once we get into past midbrain, we would then be in our more superior brain regions, which will be covered at a later point in the course. Okay, so very briefly, I want to talk about the general layout of the nuclei within the brainstem. This helps you have a relatively strong idea of what nuclei you should expect and where you should expect those nuclei to be, and this is all based on the embryological development of the brainstem. So this image does a really good job of color coding different components. So what I want to point out is in the most medial aspects of the posterior region of the brainstem, that is where you would expect to find your somatic motor nuclei. So your somatomotor nuclei are going to be located relatively in the posterior component of the brainstem and near midline. Now we also have brachial motor. Remember, those are the motor components that are derived from the facial arches, but that is going to be located more anteriorly, but still in the more midline areas of the brainstem. And then we have visceral motor, a little bit more laterally, but motor is located primarily in the mid line of the brainstem, and then as we come more laterally, that is where we're going to get our sensory nuclei. So we can see that we've got visceral sensory, special sensory like hearing, and then general sensory, so GSA fibers, and that would be your spinal trigeminal nuclei and spinal trigeminal tract located in that region. So this is a really good review slide just to give you a general idea of the layout of the brainstem nuclei, but think motor more medially, and as you work your way laterally, you are going to be looking for sensory nuclei, and that will help you have an idea of what nuclei to expect at different regions of the brainstem. Now, going into the different components of the brainstem, we're going to start with the medulla, specifically at the inferior portion of the medulla. And what I want to point out is we know that we're in the medulla because if we look anteriorly, we're going to see the start of the medullary pyramids. Now, at this particular region of the medulla, we are at the very bottom components of the medulla here in the closed medulla. This is where we're going to have the pyramidal decussation. If you remember, the pyramidal decussation is where you're having that crossing of the corticospinal fibers that are coming down from the brain. So right here, you can see that decussation of the medullary pyramids. Okay, so that's your pyramidal decussation, making that big X right there in the middle. It's a really important structure to know because that is going to tell you everything superior damage to a motor fiber is going to have contralateral effects in the lower body. And then anything below the pyramidal decussation, damage to the spinal cord, for instance, the damage to the spinal column would present with ipsilateral weakness in the associated muscle structures. Then we're going to talk about the fasciculi, which you saw in the spinal cord sections, but as we come more superiorly, the grassal fasciculus, right? Remember where that is in the cuneate fasciculus back here posteriorly. The grassal fasciculus is going to be located more medially, with the cuneate fasciculus located more laterally. Okay, so just going through those really quick. And then talking about our spinal trigeminal nucleus. The spinal trigeminal nucleus is going to be present in a lot of your brainstem segments. For now, it's going to be located right in this region here. So the nuclei here, and then the tract located a little bit more laterally. Again, you're going to see this particular nuclei and tract throughout much of the brainstem. Now, the spinocerebellar tract and dorsal spinocerebellar tract, remember those are continuations coming up from the spinal cord. So there's going to be located in the periphery, in the lateral portions of the brainstem, and these are going to be going towards the cerebellum. And then lastly, we're going to talk about the spinothalamic tract. The spinothalamic tract is going to be pretty difficult to see in this particular view. We're going to say that it would be roughly in this region right here. Remember that the full name is the anterior lateral spinothalamic tract. So that anterior lateral component is just letting you know it's in the anterior lateral component of this region. Now, as we go more superiorly, we're still in the closed medulla, but we've now gotten above that decussation. And so what we're looking at here, the reason I still know we're in the medulla, I see medullary pyramids up in the front, but I know I'm more superiorly because I'm starting to see nuclei. So these nuclei are the lighter colored regions in this particular image. So what's important here in the near the superior borders of the closed medulla, that is where you're going to have the cuneate nucleus and the grassal nucleus. So these are nuclei that are associated with the fasciculi that we are following superiorly. So like the grassal fasciculus is still located more medially, the nuclei is going to be located medially as well, just a little bit deeper to the fasciculus. Now, as you come more laterally, you got the cuneate fasciculus and then the cuneate nucleus more deeper as we go from the posterior to anterior in that direction. Now, once again, the spinal trigeminal nucleus is going to be located over here laterally, and then the tract is associated. Then we have the pyramidal decussation. We can see portions of that right here, but it's not. We're a little bit more superior than the last image that we saw, so we don't see the full crossing X that we saw in the previous one. Spinocerebellar tracts are still going to be located in the lateral components at this region, and then the spinothalamic tract is located a little bit deeper in that anterior compartment. Right, and then the spinal accessory nucleus, this is going to be for cranial nerve 11. That is going to be located right in this region. This isn't the best image to show it, so I can't show you the clear borders, but it's going to be the nuclei located right here in this region of the brainstem. Now, going up just a little more superiorly, we're still in the region of the closed medulla. Let's go over some of the same structures that we just talked about. So in the midline of the closed medulla, that's where you're going to have your nucleus gracilis. Then you're going to have your nucleus cuneatus a little bit more laterally. Then you have the fasciculi that are associated with each one. So that would be your cuneate fasciculus, your grassal fasciculus more medially and your cuneate fasciculus more laterally. The spinal trigeminal nucleus is still located laterally in this region with its associated tract. Pyramidal decussation right here in the front, although we can see that we're a little bit more superior to this because the medullary pyramids are becoming a lot more defined. The nucleus ambiguus is going to be located in this more medial and anterior portion. Right, that's going to be your bronchiomotor components located in this region here. Spinocerebellar tracts, again, staying laterally throughout the majority of their course until they get to the cerebellum. So you would have a ventral spinocerebellar tract and a dorsal spinocerebellar tract. Then more on the anterior component, a little bit deeper, that is where you're going to have your spinothalamic tract. Your spinothalamic tract will start to migrate a little bit more posteriorly as we move up the spinal cord, but for now it's still going to be located in this rough region. Now I want to point out, you see right here, there seems to be another light colored region that's separate from the cuneate nucleus. This is your lateral or accessory cuneate nucleus. Okay, so located right in this region, separate from the cuneate nucleus, that is your accessory cuneate nucleus. Now we're starting to get a little bit of our inferior olivary nucleus right here. We'll see this a little bit in a lot more detail as we move superiorly, but know that as we get towards the anterior or the superior portions of the medulla, we're going to start to have the inferior olivary nucleus shown. And remember that from our external views that we have an olive on the outside, and underneath that we have our inferior olivary nucleus. Right? And then we're going to cover a little bit of these other nuclei and regions as we move more superiorly. I just want to let you know that these other structures could be seen in this particular view, although they're not in the greatest detail here. All right, so as we move a little bit higher, we're still going to see a lot of the same structures, but now we see that inferior olivary nucleus coming into a lot clearer view. So this is helping me know that I'm still in the medulla, but I'm starting to get more superior in that portion of the medulla. So if we look posteriorly, we still have the nucleus gracilis, nucleus cuneatus, the lateral cuneate nucleus is still present, but now we have that inferior olivary nucleus. And that inferior olivary nucleus has a very distinct structure, so it's a really good landmark to use as you're making sense of these structures. The spinocerebellar tracts still located laterally, right, as they're getting ready to go into the inferior cerebellar peduncle to get to the cerebellum. That's not quite happened yet, but it's getting there. Then we have our spinal trigeminal tract located again in the anterior lateral components. Now, what I do want to point out is that we do have a central tegmental tract that's now going to be starting to be located here in the olivocerebellar tracts. What this is showing, the central tegmental tract is going to be coming from above, superiorly, running down to your olive. It connects the red nucleus and the olive, and you have the olivocerebellar tract, which is connecting the olive, or the inferior olivary nucleus, to the cerebellum. So that's going to be some of these fibers that we see here, whereas the fibers on the lateral part we would be considering the central tegmental fibers. But we're going to see these fibers, especially central tegmental fibers, running superior to inferior throughout the brainstem from levels between the red nucleus and the inferior olivary nucleus. Now, what I do want to point out is, remember, at the level of the nuclei, right, the fasciculi that correspond to the gracile and cuneate nuclei, those were primary sensory fibers. Once they synapse, they are now becoming secondary sensory fibers. So those secondary fibers are now going to decussate at the level of the nuclei. So that is what we're seeing here. We're seeing those fibers coming across and decussating, so they're going to the opposite side. So once you have secondary sensory fibers, they are going to decussate and go to the other side, and they are going to run in this medial tract that is promptly named the medial lemniscus. So this tract that we see here, especially the anterior components, is going to be the medial lemniscus. Now, the more posterior regions here, that is going to be termed the medial longitudinal fasciculus. You can identify this component at pretty much every single brainstem level, but the main fibers that are running through the medial longitudinal fasciculus, as we get a little bit more superior, is the medial longitudinal fasciculus allows communications between the cranial nerves that supply the motor components of your eyes. So that's going to be cranial nerves 3, 4, and 6. So right here we're below that, so we're not going to have those components. But as we go more superiorly, that's going to be the majority of what that fiber pathway is maintaining. All right. And then talking about looking at the posterior regions, if you remember from our looking at the rhomboid fossa, as we're getting into the open medulla, we are going to be able to see the hypoglossal trigone and the vagal trigone. So here in this view, because we're looking at the internal structures, we would be able to see the hypoglossal nucleus and the vagus, the motor nucleus of the vagus nerve. So right here, we're a little bit not quite in the region of the full open medulla, so it's really hard to tell individual nuclei, but this would be the region of your hypoglossal nucleus. Right, and then the dorsal motor nucleus of cranial nerve 10 is going to be located a little bit more laterally. Right, but as we get to the region of the open medulla, this is going to be a little bit clearer to see. And then your nucleus solitarius and the tract, that is this tract that you see located more laterally. We're going to point out in a little bit clearer view that this is going to be located laterally to the sulcus limitans. So the sulcus limitans would be roughly in this region. Again, it's just hard to see because we're not fully in the open medulla here. Okay, so now we've gotten a little bit higher. now we're in the region that we're pretty confident we can say that this is the open medulla here. So what I want to point out is that right here, this little indentation is going to be the sulcus limitans, and you saw this from an external view as well. But this is a really good landmark because it's going to, for the most part, divide motor nuclei from sensory nuclei more laterally. So motor nuclei more medially, sensory nuclei more laterally, sulcus limitans being that divide. And again, look back at that image that we showed at the beginning of this video of the layout of the general brainstem nuclei to kind of go over that component. Now, what I want to point out, we still have the inferior olivary nuclei here. So we know we're in the medulla. We have our medullary pyramids. Remember, those are the corticospinal fibers coming down. We still have this very large medial lemniscus. And remember, these are the secondary sensory fibers that were coming from the nuclei of the cuneate nucleus and the gracile nucleus. Okay, as we go into the more posterior regions of this medial longitudinal fasciculus, that is where we're going to, the medial lemniscus, you go more posteriorly, this is now the medial longitudinal fasciculus. Okay, just that more posterior components in this region. All right. Now, the spinal trigeminal nucleus is still going to be present. That is going to be located laterally. And then the tract that is associated with it is a little bit more laterally to that. So the nucleus, spinal trigeminal nucleus, spinal trigeminal tract located more laterally. Now, here we can see in a lot more detail the nuclei for the hypoglossal nucleus and the dorsal nucleus of the vagus nerve. So let's start with the hypoglossal nucleus. In the region of the open medulla, the hypoglossal nucleus is going to be located more medially. So right here is going to be the hypoglossal nucleus. Now as we go more laterally, so here's our sulcus limitans, so everything medial is going to be motor. So right here, that is going to be the dorsal motor nucleus of cranial nerve 10, which is your vagus nerve. Right. Now that we've gone past the sulcus limitans and we're going more laterally, this is going to be sensory. That is where we're going to have our solitary nucleus located right in this region and our solitary tract right here. We come a little bit more laterally, and this is where we're going to get into our vestibular area. There's going to be different nuclei, which we're not going to go into detail on in this particular video. Now up here in the anterior lateral, or not quite all the way in the anterior lateral component, but anteriorly, a little bit more medially, this is going to be the general location of your nucleus ambiguus. Okay, so that is, again, the bronchiomotor component, and that's going to be located in this rough region here. And then lastly, I want to point out, we are now getting into the inferior cerebellar peduncle region. So this is where those spinocerebellar fibers are going. They were going from below, and they are now making their way into the inferior cerebellar peduncle to get into the cerebellum. Okay, and we're going to continue our pathway as we move up. So we are now getting into the region of the caudal pons. So we've left the open medulla, and we're now getting into the pons. So the way that I can tell that this is the pons is I can see these corticospinal fibers located within the pons anteriorly. Okay, so there goes your corticospinal fibers going from the cortex to the spine located anteriorly. Now, what I do like to point out is we can still see the inferior cerebellar peduncle here. This is, again, because we're at the caudal pons, the more inferior region of the pons. But one of the most important things that helps me identify that this is the pons is because there are going to be fibers that run from the pons to the cerebellum, and that is going to be via the middle cerebellar peduncle, which is this component that we see here. So you see that middle cerebellar peduncle running posteriorly to get to the cerebellum from the pons. Now, the sulcus limitans is still going to be present here, and the sulcus limitans is located right here. So again, remember that sulcus limitans is dividing motor nuclei more medially from sensory nuclei more laterally. With that said, we have gone more superiorly, so we're no longer going to see that vagal nucleus, the vagus nucleus, or the hypoglossal nucleus. We are now in the region of the facial trigone, or the facial colliculus. So in this region, we're now going to have the abducens nucleus located more medially. So abducens nucleus is located here. Right. What I want to point out is we do still have that medial longitudinal fasciculus located right here at the posterior components, just anterior to those more posterior located nuclei, so medial longitudinal fasciculus, and the medial lemniscus is still present. It is now located a little bit more anteriorly, but still in that medial compartment. spinal trigeminal tract and spinal trigeminal nucleus are still here. They've been present all along. So here goes the tract with the nucleus associated. And here we're going to be able to see two cranial nerves leaving the brainstem. So the first is going to be cranial nerve 7. The facial nerve is going to be exiting right here. So that's the facial nerve exiting the brainstem. And then you're going to have cranial nerve 8, the vestibulocochlear nerve, exiting the brainstem as well. Now, again, I do want to point out as we go laterally to the sulcus limitans, this region over here is going to be your vestibular area. So there's your vestibulocochlear nerve. So there are going to be various nuclei associated with this region, which we're not going to go into detail in this particular video once again. And lastly, I want to point out the central tegmental tract. So again, remember the central tegmental tract is the fibers that are communicating from the superior red nucleus down to the inferior olivary nucleus. So in this particular view, the central tegmental tract is located right here in this region here. Now, I know some of you are thinking, hey, can't you see the facial nuclei? Can't you see the superior olivary nucleus in this particular view? And while they could be distinguished, it's just not a very clear view. So we're going to go slightly higher to get a better view of those particular structures. So now we've gone a little bit higher. We're still in the pons. Again, we have those corticospinal fibers coming down from the cortex down to the spine anteriorly, and that's going to make up your pons. And then we're going to have communications from the pons to the cerebellum posteriorly via the middle cerebellar peduncles. Okay, so these are good landmarks to have when you're identifying the level of the pons. Once again, the sulcus limitans is still present here. It's a lot clearer to see in this particular image than the last one. So there goes that little indentation there for the sulcus limitans. And that's going to denote motor nuclei more medially, sensory nuclei more laterally. That's the general idea behind where the sulcus limitans is located. So, again, laterally to the sulcus limitans is where you have that vestibular area. Because remember, the vestibular cochlear system is going to be primarily for hearing and auditory sensation, along with the vestibular sense, which is going to also be a sensory component. Now, anteriorly in this posterior component, we are going to have the medial longitudinal fasciculus. It's just a continuation from the view we saw previously. If we go more anteriorly, we're going to see these fiber pathways. That is going to still be your medial lemniscus. So your medial lemniscus is still present here. And we can see the the central tegmental tract still located in the same position that it was in the more inferior view. Now, what I do want to point out is we can see our abducens nuclei as well as the nerve. So here is the nucleus. And then here is the nerve coming out anteriorly. Remember that the abducens nucleus the abducens nerve comes out anteriorly in the pons, right at the base of the pons. So there, right here is where we can actually see that abducens nerve running from the abducens nucleus anteriorly. So abducens nucleus, abducens nerve. Okay, and then we are going to be able to see their facial nerve here. Here goes the facial nerve as it's making its way to exit the brainstem. And the motor nucleus for the facial nerve is located right here in this region. Probably a little bit better to see over here. So that facial motor nucleus is then going to send fibers around the abducens nerve or nuclei, and then they're going to exit the brainstem. So there goes the nerve components, and there goes the motor nucleus. All right. Now, I do want to point out, as we get into the level of the we're up in the mid-pons area, and we can see that because we have the fourth ventricle located posteriorly. This is now where we're going to start to see the superior olivary nucleus. Now, the superior olivary nucleus is a component of your auditory sense. So the superior olivary nucleus is located right here in the anterior components of this region. And what I want to point out is that the superior olivary nucleus is going to then send fibers that are going to communicate with the inferior colliculus in the tectum, and that is going to be via a tract called the lateral lemniscus. So we had our medial lemniscus, and now we're going to have our lateral lemniscus, which is going to be present a little bit more laterally. And again, central tegmental tract located here. Now, while we have the medial lemniscus here, I do want to point out that the more lateral components right here, this isn't the lateral meniscus, but this is the spinothalamic tract. So the spinothalamic tract, again, is carrying that pain and temperature sensation from the lower parts of the body as well as the face, and it's going to be ascending in this region lateral to the medial lemniscus. Right here, this nuclei is the superior olivary nucleus, and this is your facial motor nucleus, giving rise to the facial nerve. Here's your abducens nucleus, giving rise to the abducens nerve. Medial longitudinal fasciculus here, medial meniscus located in the anterior portion, vestibular area located lateral to the sulcus limitans because that is sensory information. Pons located anteriorly with the medial cerebellar peduncles going back to the cerebellum to allow communication between the pons and the more posterior located cerebellum. As we continue our journey and superiorly, we are now getting in towards the superior portions of the pons / midbrain. So this is kind of an in-between view. We can still see that we have components of the pons anteriorly, but once we get up here into where we can see the tectum, we're now roughly in the region of the midbrain as well. So some major components that we're looking at here to identify level is I look posteriorly and I see that I have one of the colliculi. It's either the inferior colliculus or the superior colliculus. I then have to determine which one of it is it. And then I see anteriorly, we have the pons. So if I have the pons and a colliculi in the same view, it is most likely going to be the inferior colliculus, which is what we have here. Remember, these fibers in the pons are going to be corticospinal fibers that are shooting down towards the spine, along with some other fibers, but that's the ones that we're primarily concerned with. And then I want to point out one of the easiest structures to identify, in my opinion, and a great landmark for getting up into the midbrain is going to be the periaqueductal gray. So remember, we have the cerebral aqueduct that's communicating between the third ventricle and fourth ventricle. So as we're going more superiorly to the fourth ventricle, we would be expecting to find the cerebral aqueduct, which is this structure located here, and the region around it is the periaqueductal gray. Okay, so this is a pretty easy structure to identify, and so I use it a lot as the determination of getting into the midbrain. Now, I do want to point out, we mentioned that there was a fiber pathway that was going from the superior olivary nucleus to the inferior colliculi. So here's the nucleus of the inferior colliculus, and you see that there's a fiber pathway that seems to be connecting to it. That fiber pathway that is connecting here to the the inferior colliculus is going to be the lateral lemniscus. So that lateral lemniscus communicating here to connect with the inferior colliculus. Now there are a couple other structures that I do want to point out here in this view. So right here in the anterior component of this view, this is going to be the decussation of the superior cerebellar peduncles. So the decussation of the superior cerebellar peduncles. All right. Now I do want to point out a little bit more anteriorly, while we have the lateral lemniscus synapsing with the inferior colliculi, the medial lemniscus is going to go all the way to the thalamus. And remember, those are containing those secondary sensory fibers that decussated from the nucleus cuneatus and nucleus gracilis. So that is going to be located right here in this region. So that is your medial lemniscus. As we come more laterally, this is where we're going to have our spinothalamic tract. Right, spinothalamic tract located just lateral to the medial lemniscus. And again, right here anteriorly, right here at the anterior portion of the cerebral aqueduct, that is where we're going to find the medial longitudinal fasciculus. The medial longitudinal fasciculus is again communicating between the abducens nucleus and cranial nerves 3 and 4, which is your oculomotor and trochlear nerves, which are going to be located at this. We'll see them in a little bit more detail as we go more superiorly. Located roughly in this region here of the periaqueductal gray. So this medial longitudinal fasciculus is allowing communication between those nuclei, which is a really important point to make. Okay, and now we're going to continue our journey a little bit more superiorly into the midbrain. And now here's where we're going to be able to clearly see the nucleus of the oculomotor nerve. But again, how do I know that I'm in the midbrain? I look for the periaqueductal gray along with the cerebral aqueduct. And anteriorly, and now I'm fully in the midbrain, I no longer have the pons, but I have the cerebral peduncles. So cerebral peduncles located anteriorly. And this anterior component that has corticospinal and other fiber pathways, but primary motor motor information that's descending, that is your pes pedunculi. So that's that darker region located anteriorly. We go a little bit more posteriorly to that. You see this lighter region. That is going to be the substantia nigra. And there's going to be two components to this, but we're not going to go and differentiate between the two. We're just going to say that your substantia nigra is located right here at the more posterior components of your cerebral peduncles. Now, again, anteriorly here, we still do see that decussation of the superior cerebellar peduncles. Right, so that's that decussation there. If we go more posteriorly, again, here's our cerebral aqueduct, perioculoductal gray. Then right here is going to be the oculomotor nucleus. So this is your nucleus for cranial nerve 3, which is going to control motor sensation to the majority of the muscles of the eye, along with parasympathetic innervation. So remember, your parasympathetic nerves are cranial nerves 3, 7, 9, and 10. So each one of those is going to have a parasympathetic component. The oculomotor nucleus is going to give rise, the Edward Westphal nucleus that's associated here is going to give rise to that parasympathetic innervation that is associated with cranial nerve 3. The solitary nucleus and tract that we were looking at earlier in lower brainstem sections is going to be the parasympathetic nuclei region for cranial nerves 7, 9, and 10. Okay, now I look posteriorly and I still see that I have a colliculus. However, I no longer see the pons more anteriorly. I see the oculomotor nerve or oculomotor nucleus. So that is going to let me know that I'm more superior than I was previously, and this is now going to be the superior colliculus. But if I look a little bit laterally, so both of the colliculi are then going to communicate to more superior brain regions, and they do this via the brachiums. So remember back to looking at the external views of the brainstem. This brachium located just lateral to the superior colliculus is going to be the brachium of the inferior colliculus. So brachium of the inferior colliculus, and then the superior colliculus located more medially. Again, medial meniscus located up here in the anterior component. So medial meniscus is located right here. We go more laterally and we get the spinothalamic tract. The central tegmental tract that we've been following as we've gone more superiorly, you can just barely see it in this region here. The reason that it's starting to go away is this is also where we're starting to get the red nucleus, and we're going to see that in a lot clearer view in our next slide. But the central tegmental tract and red nucleus are located right in this region here. Again, medial longitudinal fasciculus located right here on the borders of your oculomotor nucleus. And the reason for that is, once again, the medial longitudinal fasciculus is communicating between cranial nerves 6, 3, and 4. So those are the nuclei that are going to supply the muscles that control eye movement. So it's important for the coordination of your eye movement, which we'll talk about in a later component of the course. All right. So lastly, we're now getting into the most superior components of the midbrain. So again, how do I know that I'm in the midbrain? I look anteriorly and I see the cerebral peduncles. And then the cerebral peduncles are made up of the pes pedunculi located more anteriorly. That is that motor component, those motor fiber tracts going from the cortex down inferiorly. And then just posteriorly to that, I have the substantia nigra. So that is going to make up my cerebral peduncles, the pes pedunculi, and this substantia nigra. Now, we're seeing a more inferiorly, we saw the decussation of the superior cerebellar peduncles, but now we don't see that in as much detail, but we see these nuclei here. This is the red nucleus. Remember that red nucleus was communicating down to the inferior olivary nucleus via the central tegmental tract, but now we're seeing the red nucleus here. So remember, the red nucleus is located pretty superiorly in your brainstem, up at the superior portions of the midbrain. Now, more posteriorly, again, we are seeing the superior colliculus here. But what I want to point out is, if you think back to where are the colliculi communicating to? The inferior colliculus was communicating to the medial geniculate nucleus, and the superior colliculus was communicating to the lateral geniculate nucleus, and they do so via the brachiums, which are the arms. So what we're looking at here is the superior colliculus. I go slightly more laterally, and I see a fiber pathway. This fiber pathway is the brachium of the inferior colliculus. So superior colliculus, brachium of the inferior colliculus, and that brachium is then going into the medial geniculate nucleus. So there's the medial geniculate nucleus located here. Now, you can, in this particular view, see the lateral geniculate nucleus located more laterally to the medial geniculate nucleus. So medial geniculate nucleus, lateral geniculate nucleus. Remember, superior colliculus communicates to the lateral geniculate nucleus. Inferior colliculus, which we can't see in this particular image, is communicating with the medial geniculate nucleus. And finally, we're still going to have components of our medial meniscus as it's making its way to the thalamus, as well as our spinothalamic pathway. They have just started to migrate throughout this process from a more medial location to a more lateral location as we get towards the thalami. And with that, that should bring a close to this particular video.